Okay, on number 17, this one is like number 13. Remember on 13 how we had that 16m on one side, and so if they put stuff on both sides of the equations, we have to move everything to one side. Because I got to have a 0 on one side, because the only reason I can solve these things is that I have that zero product property. It's the only reason I can actually solve these. So if I need to get 0 on one side, I need to move all the terms to one side, and you always kind of want to keep this square term positive. So what I'm going to do is I'm going to move that 16y back over to the other side. When I move it, remember I can move terms from side to side by adding or subtracting them by doing the opposite. 16y minus 16y, when I do that, what is something minus itself always equal to? 0. So that's why this works. I got to get a 0 there. And now I have y squared minus 16y. Okay, so that's what I got to factor, is y squared minus 16y. Now, remember, what's the very first thing I should always check for when I'm factoring? GCF. Is there a GCF here? Yes, y. I can take the y out here because there's not a number sticking on the end that messes it up, right? So I can factor that y out. Y squared, if I take the y out, there would be a y left, and then minus 16y, if I take the y out, wouldn't there be a minus 16 left? Oh, and I got my 0 on the other side. Life is looking good here, right? I didn't even have to do the little, add to get this, multiply to get this, and add to get the middle term. I didn't even have to do that here because I've got two things multiplied by each other. So one thing, remember, I could have looked at this as being, if I want to say, well, only the things in parentheses go equal to 0, well, I can stick a parentheses around that. It's just the way they chose to write it. So that factor y could be 0, and this factor here, y minus 16, could also be 0. Now this one, there's nothing to solve, is there? Y equals 0 is one of my answers. There's nothing to solve there. I don't have to move anything from side to side to get y by itself. It's already by itself, isn't it? Y minus 16, then, I just have to say, well, to get y by itself, I add 16 to both sides to solve for y. Oh, y is 16. There's my two answers, and remember, I can write them like that, or I could put them in these fancy braces. These are called braces now. I remember what they're called. And usually list them from least to greatest. So I would put my 0, and then I put my 16. This is just saying I got two answers. Here's a list of them. There's 0 and 16. There's so many little things they do to make this stuff look harder than it is. Tell me, is this the same thing as this? Can I switch the sides on equal signs and it still be okay? Yeah, and so that's what they want you to do here. They're just messing with your head because there's lots of times when you solve things that it may come out looking like it did on that first line up there. I can just say, if two things are equal, you can switch on what side of the equal sign they're on. You just flip it around and you've got this. Now this looks better, doesn't it? I got two terms. I should always first check for what? GCF. Is there a GCF here? A 2, and how many y's can I pull out? Yeah, there's y squared. I can pull a y squared out. Both of them have 2 at least. Okay, so if I look at the first term, there's my GCF. Here's my leftovers. I've got 4 divided by 2 would give me 2. And if I had y cubed and I took y squared out, it's like saying I had 3 and I took 2 y's out, I'd have 1 y left, wouldn't I? I'm going to copy down my subtraction sign. Now, if I have 2y squared and I divide 2y squared out of it, it's not 0, is it? It's 1. Anything divided by itself is 1, so I've got to put that 1 in there or I've messed up. If you think about it, if you want to get the expression on the second line back, I can always distribute this and I should get back what was on the line before it. So I got two things to set equal to 0. I've got this 2y squared to set equal to 0. And then I got the parentheses to set equal to 0. And so let's see. Let's start solving the 2y squared equals 0. Okay, so then we're just solving. If I want to get y by itself, this looks a little bit weird because we haven't run into this in this section yet. I could divide both sides by 2 to get rid of the, if you think about PEMDAS backwards, I'm trying to think, well, what do I do first? When we solve, we do PEMDAS backwards, so I would add or subtract first. There's nothing to add or subtract. So I would multiply, divide next. That's y divided by 2. That would give me back y squared equals 0. Okay, so I did that step. There is an exponent in there. How do you get rid of a square? What's the opposite of squaring something? Square rooting. Yeah, square rooting. So I could square root both sides, and I would get square root of y squared is y, and the square root of 0 is 0. So I've got, there's one of my answers. And then for the other answer, I have to solve for this y, don't I? Okay, if I'm doing PEMDAS backwards, I would add or subtract first. So let me add 1 to both sides to move that over to the other side. So I have 2y is equal to 1. The next step up would be multiply or divide. Okay, I have the y multiplied by 2. The opposite of multiplying by 2 is dividing by 2. Yep. And then, oh, I'm done. It's y is equal to a half. There's my 2 answers there for 29. Can't get it circled. Why won't you work? There we go. Oh, this one, 4s minus 4s squared is equal to 1. Okay. Now, there's not a 0 on one side, so what do I need to do? Yeah, I'm going to subtract 1. I'm going to move all the terms to one side. Now, I could subtract 1 from each side, but I want you to notice something. Look at that square term. Normally, that's what I would do here. But let me stop for a minute, because look at your square term. Isn't it negative? Do you like negative squares? No, because out front that we can't factor that. So let's do this. Normally, I would move the 1 to the other side, because usually you move the less amount to the side that's got more terms. But here, what I'm going to do, I'm going to move all the other terms over to the right, because if I do that, that'll make my s squared term positive. And I sure don't want, so this would be 4s is equal to 4s squared plus 1. And now let me go ahead, I can move this one over there also. It's a positive 4s, so if I subtracted 4s from both sides, that would give me 0. I could have done all that on one line. I'm just splitting it up into 2 lines because I know some people don't think, oh, let me do all of that at one time. They're just kind of doing one little step at a time. Now, I can't combine that 4s with anything else because remember, for a like term, you have to have the same letter and the same exponent. So I can't really do that. Now, this is one of those harder factoring problems. I want to show you why the book took some time to do something called a binomial square, okay? When we have these harder factoring problems, we could either guess and check, or we could complete the square. But do you remember that you had some of these problems before you ever learned any of that? Do you remember there was a section called perfect square trinomials? And if you remember, this is one of the reasons I like those. If you look at this first term, and it's a perfect square, it's 2s, isn't it, squared? And look at the last term, isn't that 1 squared? Do you remember that, if I multiply those two things together, I'd get 2s, and I doubled it, I would get 4s. Look at the middle term. If you remember, with a perfect square trinomial, if the first term was a square and the last term was a square, and I multiply those two things together, I multiply the 2s and the 1 together, I get 2s, but then I doubled it. That would give me a 4s. Isn't that what my middle term is if I just tweak the sign a little bit? How am I going to get a negative 4s? What if I made that a negative 1 squared? Let's see if this works. 2s minus 1 and 2s minus 1, because if you remember what that lesson told us was that I could do, if it works out this way, it could just be 2s minus 1 squared is how I factor it. Let's check it and see, because I don't know about y'all, I don't like factoring those kind of problems, and if I can get around it without having to do so much work, I'm all for that. Let's see, let's multiply this out and see if this works. 2s times 2s is 4s squared. 2s times negative 1 is negative 2s. This negative 1 times that 2s is another negative 2s. Don't those add up to negative 4s in the middle? And then negative 1 times negative 1 is a positive 1. Hey, I factored that, and I didn't have to go guess and check, and I also didn't have to complete the square. You see now why it might be kind of handy to know that section, even though we didn't like it so much? It gives us another way to factor some of these without having to go do those guess and check or that long factoring by grouping type thing. I can factor it that way. I could use any of those other ways I wanted to also. But if you look at this, This is the same thing as the zero's just on a different side, right? I could rewrite this way if I wanted to. Not that you have to. You just have to have one side equal to 0. Isn't that the same thing as the step before it? All I did is switch the sides around again. So if I want to solve this, either 2s minus 1 equals 0, or look, it's the exact same thing. 2s minus 1 equals 0. Do I have to solve both of those? When I do it once, it's going to be the same answer for both parts, isn't it? Okay, so let's just do it once and just realize that I would move, remember we add or subtract first when we do PEMDAS backwards and we're solving. So I would have 2s is equal to 1, and then to get the s by itself, I would do what? Yeah, divide by 2, both sides by 2, and I would get s is equal to a half. And I could go do the math on that second factor, but it's exactly the same factor, so why waste my time? Both answers are s equal 1/2.